PTM-1 question paper discussion. Question number 26. High purity, that is greater than 99.95 percentage dihydrogen is obtained by. So 99.95 percentage dihydrogen is obtained by electrolysis of warm aqueous barium hydroxide between nickel electrodes. B is the correct option. Next, question number 27. Match the extraction process listed in column 1 with metals listed in column 2. So we have to select the correct statement. Self-reduction method. And carbon-carbon monoxide reduction, electrolytic reduction in fused state, complex formation and displacement of metals. So self-reduction is used for the extraction of copper from the copper glands. So this should be first. Next, copper, that is carbon and carbon monoxide reduction generally we'll see in the case of iron from hematite. Fourth one, electrolytic reduction in fused state. So this is aluminium, extraction of aluminium from bauxite. So third one is C, and complex formation and displacement by metal. So this silver from argentite. 1 4 3 2. 1 4 3 2 is in option C. Select the correct statement about structure of H2O2. Dihedral angle in a solid phase is greater than gaseous phase. So this is wrong. Gaseous phase is greater than solid phase. Next, OOH angle. Solid phase is greater than gaseous phase. So this is correct statement. OO bond length in gaseous phase is greater than the solid phase. This is wrong statement. And the fourth one is OH bond length. Solid phase is greater than gaseous phase. So 2 and 4, this is the correct option. Next, select the correct statement about froth flotation method. Pine oils, fatty acids, xanthate enhances wettability of mineral particles. So this is not correct. Actually this is non-wettability, but here wettability is given. So wrong option this is. Used for the removal of gangue from carbonate ores. No, not from carbonate ores. This is what sulfide ores generally. Froth flotation method is used for the extraction of sulfur from the low grade sulfide ores, not from carbonate, that is from sulfides. So wrong statement. Cresols and aniline are used as froth stabilizers. This is the correct statement in froth flotation method. Sodium cyanide is used as a depressant to allow zinc sulfide to come to the froth. No, not, it is not allowing, it prevents. C is the correct answer for this question. Next, question number 30. Statement type of question. This is zone refining method is based on the particles that the impurities are more soluble in the melt than in the solid state of the mineral. Yes, statement 1 is correct. This is correct statement. Right. Next one is, in the refining of copper by electrolytic method, anodes are of pure copper and impure strips of copper are taken as cathode. This is a wrong statement. Right. False statement. Here not pure copper is used, blister copper is used. Instead of pure, blister copper is used. So statement 1 is true, but statement 2 is false. First option is correct. Formation of volatile tetracarbonyl nickel and then its subsequent decomposition into nickel and carbon monoxide makes basis of Mons process. So here the conditions, if you see, first one is nickel, 4 moles of carbon monoxide gives tetracarbonyl nickel at T1. So generally this reaction is taking place at 70 degrees centigrade. Next, Tetracarbonyl nickel decomposed to nickel and 4 moles of carbon monoxide at T2. So this temperature is 170 degrees centigrade. C is correct option. Next. So here hydrates are given. We have to select what type of hydrates these are. That is SiH4. Silane. Silane is nothing but silicon is 14th group element. 14th group elements are called as precise. So electron precise. Third. NH3 ammonia hydride of nitrogen. 15th group elements are electron rich. So first option is correct. B2H6 boron is 13th group elements. 13th group elements are electron deficient. So this is second one, electron deficient. Zirconium hydride 1.32, that is 1.75. This is metallic hydride. 3124. Option C is right. Choose the correct methods for each. So nickel by electrolysis process, wrong. Nickel is Mons process. Copper Van Arkel process. So actually copper is extracted by the electrolysis process. Zirconium is zone refining method. So this is wrong. Gallium is Mons process. So gallium is not Mons process, right? It is zone refining process. First one is wrong. Second one is nickel Mons process, correct. Copper electrolysis, correct. Van Arkel method and zone refining. So B is the correct option. Which of the following physical property is higher for H2O than D2O? Density. Density is more for D2O. So this is a wrong statement. H2O we have to select. Viscosity is also more for D2O. And temperature of maximum density. So temperature of maximum density is also not related to the H2O. Dielectric constant is highest for H2O, that is 81 to 82 we can write, which is dielectric constant value. Highest for water. Next. Match column 1 with column 2. So let us see what ores. Aluminium. Aluminium ore is kaolinite, that is second one. So what is the formula of this kaolinite? Kaolinite formula is Al2 Si2 O5 OH taken 4. This is the formula of kaolinite. So it is the ore of aluminium. Next, let us see zinc. So zinc is what you call zinc calamine. First option. Formula is zinc carbonate, ZnCO3. So ore of iron is siderite. Fourth one. Formula of siderite is iron carbonate. Next, copper ore is copper ore malachite. Third one. So it is a carbonate and hydroxide of copper. That is copper carbonate CO3 dot copper hydroxide. So 2143. 2143, that is D option is correct. Next, question number 36. Correct statement we have to select. Mixture of CO and H2 is called as syngas. Yes, correct statement. Industrial dihydrogen is mostly produced from petrochemicals. So this is also correct. Carbon dioxide formed in water gas shift reaction is removed using iron chromate. Right, this is a wrong statement. Actually, whatever the carbon dioxide is formed, that can be removed by scrubbing method. Right, generally sodium arsenate is used. This is not by water shift reaction, it is by scrubbing method. Wrong statement this is. Next one is Production of syngas from coal is coal gasification. This is also correct statement. So first, second and fourth, C is the correct one. Next, select the correct statements. Pig iron contains 4% carbon, right? Correct statement. Cast iron contains 3% carbon, correct statement. Copper formed after evolution of sulfur dioxide is blister copper. Yes, this is also correct statement. Copper mate contains Cu2s and Fe2. Wrong, not Fe2. This is Fes only. That is iron sulfide. So first three statements are correct. B option. Choose the correct statement. In the hydrogenation of vegetable oils, nickel is used as catalyst. Correct statement. Dihydrogen is obtained as a byproduct in the electrolysis of fused NaCl. Correct statement. Next one is in the preparation of methanol from carbon monoxide and hydrogen, cobalt is used as a catalyst, not cobalt. Here the catalyst used is metals like copper, even Al2O3 also we can use, zinc oxide also we can use. So wrong statement. Hydroformylation of olefins gives aldehyde. This is correct statement. So first, second and fourth, B option is right. Next, select the correct statements. Impurity in ruby is chromium, right? So this is correct statement. Next, iron is the second most abundant element in the earth crust, not iron. Oxygen is the second most abundant element in the earth crust. So wrong statement. That is impurity in sapphire is cobalt. Yes, this is correct statement only. Aluminum is the third most abundant element in the earth crust. Yes, 1, 3, 4. That is option B is right. Next, match the following type of question. This is, here it is coordinated water, interstitial water and hydrogen bonded water. Coordinated water is nothing but hexa aqua chromium 3 chloride. That is third one is the correct for the coordinated water. Next one is interstitial water. Interstitial water is first one. Example is BaCl2 dot 2H2O. Next, hydrogen bonded water is there in the case of copper sulfate, dot 5H2O. Next, 3, 1, 2. B is right. Select the correct statement. That is, wrought iron is used in making railway sleepers. No, this is not wrought iron. This should be cast iron. Wrong statement. This is nickel steel is used in making aeroplane parts. Yes, why? Because nickel steel is a lighter one, so that is used. Chrome steel is used in making crushing machines. Yes, this is also correct statement. Why? Because chrome steel is a hardest substance. I mean, that is very hard, so it is used in the crushing of machines. Second, third and next fourth one, if you see, cast iron is used in making agriculture, what you call implements. Agriculture implements, not cast iron. Generally wrought iron is used. So second and third, this is wrought iron. (42nd). That is, ice crystallizes in a hexagonal form at atmospheric pressure, but at low temperature it condenses to octahedral form. So this is wrong statement, right? False statement you can say. Next, second one is, hydrogen bonding gives ice an open type structure with wide holes. This is correct statement. So statement 1 is false, statement 2 is true. C option is right. Next, Ellingham diagram, which is very important. We discussed the same diagram in the class also. Let us see. different metal oxides are given and reducing agents are also given. So in this, to make the following reduction process spontaneous, temperature should be zinc oxide on reduction will get zinc metal and carbon monoxide. We know that whatever the reducing agent or metal is present below the zinc oxide can reduce. Okay, now can reduce above the metal. Now in the graph zinc oxide, so zinc oxides can be what you call reduced by which at what temperature we have to select. So this less than 1000 is given, greater than 1000, less than 500, and greater than 500 but less than 1000 degrees centigrade. To make the reduction process spontaneous, generally what happens here, above 1000 degree centigrade is used. Above 1000 degree means here it is what zinc oxide, here carbon is there, right? So above 1000 degrees, that means above this part, here it becomes what zinc oxide. So above 1000 degrees it can be reduced. Carbon can reduce above 1000 degrees centigrade. Next, select the correct statements about hydrides. Lithium hydride is unreactive with oxygen and chlorine at a moderate temperature. Correct statement, because it is what you call whatever the lithium hydride is there, that is highly unreactive substance. Next, metals of group 6, 7 and 8 do not form hydrides. So this is also correct statement. Why? Because 6th, 7th, 8th do not form hydrate, but exception is there. That is what a 6th group element, that is chromium, can form hydrates. Chromium hydride. Okay. So here 6th is included. That's why you can eliminate this. That is what you call second. No need to consider. No need to consider. Reason is what? Here 6th is there. 6th group chromium is forming hydrides. Right. So generally 6th, 7th, 8th, that group is called as hydride gap. Reason is they are not reacting with hydrogen to form hydrides. So wrong statement only you can consider second one. Beryllium hydride and magnesium hydride are polymeric. Correct statement. Law of constant composition does not hold good for saline hydrides. So this is also what you call wrong statement only. 1, 3, C option is right. Select the correct statements. Brass is a combination of copper and zinc. Correct statement. Bronze is the combination of copper, tin. Yes. German silver is copper, zinc, nickel. Correct. Next, coin is alloys copper, nickel. This is also correct. All are correct. D option is correct. Next. The number of reducing agents involved in the extraction of iron as pig iron using blast furnace from the hematite ore is, yes, here we are using how many? Two reducing agents. The two reducing agents are, one is carbon monoxide and the other one is carbon is used, right? So generally carbon monoxide is used in the reduction of that is what ferric hydroxide, that is ferric oxides, Fe2O3 plus CO gives rise to Fe plus CO2. How many moles? Here you have to take 2 moles of Fe, then here you have to take 3 moles of CO, then 3 moles of CO2. So CO is enough here. And coming to the second, carbon is also reducing iron oxide, FeO plus C gives rise to Fe plus CO. So totally how many? Two reducing agents are used in this case. Next. 47. So 47th one, if you see this 47th one, calculate mass of zinc. Atomic weight of zinc is given 65. Required to recover silver from a 500 ml solution of 0.5 molar sodium argentocyanide. Give your answer by multiplying with 8. Okay, so let us see this one. Here I'm going to take this, right. The reaction is generally 47th question, right? If this is hydrometallurgy process is used. Hydrometallurgy method is used. In this, the reaction is sodium AgCN taken twice plus zinc gives rise to, here 2 moles you have to take, Na2 ZnCN taken 4 plus 2 Ag. Silver is precipitated, right? If we observe this reaction, zinc and silver mole ratio if observed, right, the mole ratio is of zinc to silver is equals to 1/2. That means 1 mole of zinc and 1 mole of silver, 2 moles of silver is formed in this reaction. Is it clear? So in generally zinc is used in this, whereas which one is collected? Zinc. So this is, it is used in the process, whereas silver is recovered. Silver is recovered in this reaction. So mole ratio we got, that is 1/2 is the mole ratio. So 1/2 mole ratio is nothing but, here you can write that is moles of zinc is equals to 1/2 into moles of silver, we can write now. Moles of zinc is equals to 1/2 moles of silver. So in the question they have given 500 ml of solution of 0.5 molar solution of argentocyanide, right? So concentration in terms of moles, I'll write this. Moles is equals to, what is the formula? Molarity into volume. This is in liters. So molarity is 0.5, volume is given 500 ml, that is nothing but 0.5 liters only, that is equals to 0.25 moles. 0.25 moles. So in terms of moles I'm taking this, right? So what is the formula? Moles of zinc is equals to 1/2 moles of silver. Then moles of zinc is equals to 1/2 into moles of silver is how much? This is moles of silver only, 0.25, that is equals to 0.0, 0.1. 0.125. This is equals to moles of what? Zinc. So here whatever the moles we got, that moles you have to multiply with atomic weight of the zinc, right? So here mass of zinc is equals to mass of zinc is equals to 0.125 into what is the mass of zinc? Mass of zinc is given in the question, that is 65. Then that is equals to how much we'll get? Let us see. That is 0.125 into 65 is equals to 8.125, right? 0.125 grams this is, right? So this is the answer we got. But in the question he said that, so give your answer by multiplying with the 8. So multiply this answer 8.125 into 8 into 8, that is equals to 65 is the answer, right? 65 is the answer for this question, right? So this is 65. Next, state of oxidation of sulfur in Marshall's acid is, Marshall's acid is nothing but peroxide disulfuric acid, that is H2S2O8. So in H2S2O8 oxidation state is equals to +6. You know how to calculate oxidation states. H2S2O8. Let us see. Sulfur you have to find out, right? So here it is having peroxy bond. You know the structure also. Yes, double bond O. There is a peroxy bond OH, OH. Here oxidation state of this oxygen is -2, -2, -2. Here also -2. But here there is a peroxy bond -1, -1. So total 2 hydrogens are there. Each hydrogen 1 plus 2 sulfurs 2x plus, out of 8 oxygens 2 oxygens -1 oxidation state, remaining 6 oxygens -2 is the oxidation state, which is equals to 0. Then that is 2 plus 2x -2 -2 -12 is equals to 0, plus 2 -2 cancel, 2x is equals to 12, x is equals to 12 by 2, that is equals to +6 is the oxidation state of what you call sulfur in Marshall's acid, peroxide disulfuric acid we can say. So it is what? +6. Next, let us see 49. Of the following, number of oxide metals is X, number of sulfide minerals is Y, number of carbonate minerals are Z. Then X plus Y minus what you call Z is, let us see the formulas. What is this? Bauxite. Bauxite is nothing but what? Hydrated aluminum sulfate, Al2O3, aluminum oxide. So this is an oxide ore. Next, calamine is a carbonate of zinc, ZnCO3. And next, sparlate is a sulfide, zinc sulfide. Malachite is a ore of carbonate and hydroxide of copper, CuOH taken twice too. Next, magnetite. Magnetite is a oxide ore, Fe3O4. Next, zincite is zinc oxide. Cuprite is oxide of copper, Cu2O. Hematite is oxide of iron, that is Fe2O3. Next one is siderite. So siderite is a carbonate of iron, FeCO3. Copper glance is nothing but sulfide ore. Now let us see which we have to select: sulfides, oxides, right? Now oxides, let us see first. X is oxides only, no? Now oxide is what? Bauxite is an oxide. Next, magnetite is an oxide. Zincite is an oxide, cuprite is an oxide, hematite is also an oxide. That's it. So total number of oxides, how many are there? 1, 2, 3, 4, 5. So here X is oxide, then that is equals to 5 plus Z. Z is what is said in the question. Z is nothing but carbonate minerals. How many carbonates are there here? Carbonates are copper carbonate, zinc carbonate. Next one is siderite, iron carbonate. So that is equals to 3 minus Z. Z is nothing but Y. Y is nothing but sulfide minerals. So what are the sulfide minerals? Sulfide, zinc sulfide is 1. Next copper glance is 1. That's it. Only 2 are there. So that is minus 2. So this is equals to 5 plus 1, that is equals to 6 is the answer. 49th one is what? 6th. Next, last one. In the given Ellingham diagram, the number of species which can be reduced by aluminium below 800 degrees centigrade. Below 800 degrees centigrade means here. This is 800 degrees centigrade. So M5, M4, M3, M2 all can be reduced by aluminium, right? Because below M4, M5, M3, M2 there is what? Aluminium is there. So generally what happens, the metal below the above metal oxides are reduced. I mean once M5, M4, M3, M2, all these 4 can be reduced by aluminium. So answer is 4. Below 800 is said, no? So answer is 4. This and this one.